Okay, what answer did you get for the bell quiz? 4. So 4. It wasn't a trick question. So what you just did is what we're learning today. This is an arithmetic sequence. So look, this is a sequence of numbers, just a bunch of numbers in a sequence. Now, how did you get that that was 4? You're saying you're adding by 2 each time. Is that what you're saying? So you noticed a pattern was happening, and you were adding by 2 each time. That's true. Couldn't I also say, stop talking. Couldn't I also say, if we were being technical, that 10 minus 8 is 2, 8 minus 6 is 2, 6 minus 4 is 2. So I could also say there was a common difference, which also meant we were adding 2. Okay, awesome. So that's what we're doing today is 11-1, an arithmetic sequence. So what makes something an arithmetic sequence is between each term, there's a common, they're going to call it difference. They're not going to say we added 2 each time. They're going to say there was a common difference of 2, the subtraction. So you take the term before the previous term and subtract it. If it's truly arithmetic, it will have the exact same thing you're adding each time or subtracting each time. It can't be something different, or it's not arithmetic. There are sequences that are not arithmetic, which is fine. It's still a sequence. It might still even have a pattern. But to make it arithmetic, it has to be the same. So let's answer question number 1. Determine whether each sequence is arithmetic. If so, identify the common difference. Because people are talking, and it's really distracting. Like, I can't even think. So here we go. Let's see if it is arithmetic. So 8 minus 5 is 3. 5 minus 3 is 3 minus 2 is. So we added 1, then we added 2, then we added 3. Was that the same thing? No, there was a pattern, but it was not arithmetic. So we'd say no. So yeah, we could recognize the pattern, and if I asked you what would the next term be, you'd be able to figure it out because you'd put 2 and 2 together. Wouldn't we next be adding 4? Which is 12, and then we'd add 5, which is, but I'm not asking you that, just making sure you understand. It's not arithmetic. There was not a common difference every time you're adding something different. Okay, number 2, identify the common difference. So you've got to be really careful with negatives. Don't mess up. Negative 9 minus negative 6. I'm going to write that out. Negative 9 minus negative 6. Negative 3, people. Negative 6 minus negative 3. Negative 6 minus negative 3. Do you see why I don't try to do it in my head? Because there's a lot of negatives going on. Don't you subtract negative makes it plus. So negative 3 minus 0. So we were subtracting 3, then we subtracted 3, then we subtracted 3. True? So we'd say yes, it's arithmetic because there's a common difference. We'll just call that D. Our difference was equal to negative 3. That's pretty easy. Finish up 1 through 10 in a jiffy. So, well, first of all, sorry. What's so confusing about this unit for people is literally just understanding the notation. I remember I used to think this unit was so hard, and it's simply because I did not know what things meant, and it's really easy. But you got to know what things mean, or else it is confusing. So everybody, we have a sequence of numbers right here, 2, 4, 6, 8. Well, we have to start somewhere. Didn't we start here? So you're saying that was the first term in the sequence. That is true. So how they would label that is they would call that A sub 1, which means the first term. So this is our second term. They would label that A sub 2. Third term would be A sub 3, and then A sub 4, and then this goes on forever. So we could go up to whatever we want, A sub 20, or whatever. Do you see what I'm saying? Now notice something. A sub 1 does not mean that's a 1. I used to think that. A sub 2, I used to think that meant that was 2. That's not what it means. So our first term was 2, our second term was 4, our third term was 6. Okay, so if I asked you what's A sub 5, you would say 10. True, we're adding 2. No, we took A sub 4 and we added 2 to it. Oh, yeah, we'll get a formula in a minute. Okay, so right here, A sub n means any term. So now do you see I'm just putting it in general? A sub n. N is the nth term, or you're going to hear me call it the any term we want. So if I said a sub 9, you know that's the 9th term. If I said a sub 200, that's the 200th term. Does everybody see? Okay, so you should be writing that on the top of your paper or something. A sub n is the nth term, or any term. So I could do any term I want there. The a sub n minus 1 means the term before a sub n. So you're going to hear me, a sub n minus 1 literally just means the previous term. So if I put an a sub n right here, the term that came before it would be a sub n minus 1. Yes, she's making a connection here. A sub n plus 1 means the term after a sub n. So right here would be a sub n plus 1. And it's written in small little things. So if you ever saw this, it's not a formula. That means the previous term. That's all that means. So you can't read too much into it. Okay, so I'm going to test your knowledge now on what notation. Ready? Don't write it down, just look. What's a sub 1? What's a sub 2? A sub 3. Okay? Well, if a sub n is 3, what's a sub n minus 1? The previous term 0, what's a sub n plus 1? Okay, true. Does everybody see how easy that was? So we know what that means. Okay, good. Now look how that works. Let's make sense of this. We said that 3 was a sub n. So then we also said 0 was a sub n minus 1. We said 6 was a sub n plus 1. Now, what was a sub n? 3 was a sub 2. True? So then a sub 2 minus 1 would have been a sub 1. Wasn't that the first term? And then a sub 2 plus 1 was a sub 3. So do you see how it makes sense? I'm just testing your notation. Okay, you're like you don't understand the notation. Okay, here we go. So look at number 11. It says find the 43rd term in the sequence. So I'm asking you to find a sub 43. Well, let's see here. We have a sub 1, a sub 2, a sub 3, a sub 4, and then it's continuing. We're going to have to go clear the freak out there, clear to the 43rd term. That will take us a long time if we try to do this by hand. Way too long. So there is a quicker way. There are some formulas that we can use to get there. So this is what's the explicit formula we could use to get there, and this is our favorite formula. So be writing that, even write the word explicit formula, because you're going to have to know the difference. So there are two formulas that we use, but actually really only one is usable. The other one we can't really use it. So I'll explain. Our explicit formula is the most usable because you don't need to know anything except for what the common difference is, meaning I need to know if I'm adding 2 each time, which we are able to tell. Isn't right here, aren't I adding 2 each time? You see what I'm saying? You need to know that, and then you also need to know where did we start? The first term, a sub 1. So we started with 12, and we're going to add 2 a certain number of times. Correct, everybody? To get up to the 43rd term. So this is the formula you can use to find any term in the sequence. So that's why it says a sub n. It's leaving it general. A sub n, any term in the sequence, will be equal to a sub 1, which is the first term. You're writing this down. Plus n minus 1, where n is the nth term. N minus 1 times by the common difference. So b is common difference. So that way, if I said find the 43rd term, that would be a sub 43. You could literally just plug in 43. If I said find a sub 100, you could just plug in 100. Easy. Yeah, and then it will calculate it, because we know what these two things are. So you'll see how this works in just a second. Now that formula is just something you need to have memorized. That's the format of an explicit formula. A recursive formula. This one is actually the easiest to write. It's literally what do you see happening, but then it's not very usable, and you'll see why in a second. So this is a sub n is equal to a sub n minus 1, which means the previous term. That never changes. It's take the previous term, and then you're adding the common difference, for example. It's literally what you see happening. So, for example, we have to find the next term, we need to take the previous term and add 2. True? The previous term, add 2. The previous term, add 2. The previous term, add 2. That's easy to write. So let's write each of these formulas out for this sequence on number 11. Okay, here we go. So let's write out our general formula. A sub n is equal to, what's a sub 1? So we started with 12 plus, we're going to leave n general, because right now I'm having you practice writing a general formula. So n minus 1, but what was our common difference? So times by 2. And now this formula allows you to find any term in the sequence. Because what can I do? If I said find a sub 43, for example, do you see how you can literally just plug in 43 and type it into your calculator? And now you have it like that, instead of having to do it a million times. So you would say 12 plus 43 minus 1 times by 2. Go, calculate it. What's our 43rd term? Yep, 96. So guys, if you added, starting with a sub 1 of 12, if you added to 42 times, because starting here we'd only go 42 more times, we would get up to 96. Our 43rd term is 96. That was way easy, right? Now I do want to say one thing. They will not leave the formula not simplified. So I do want you instead to go like this. Don't circle it here. Take 2 and multiply it in. So we would have a sub n is equal to 12 plus 2n minus 2. We're going to simplify our formula because that's how you're going to see it written on a multiple choice test. So I'm making you practice it for a reason. So a sub n is equal to, let's write it in standard form, which means highest degree to lowest degree. So we would have positive 2n's and then 12 minus 2 plus 10. So this formula would be really what we would call our explicit formula, the simplified answer. And it still works. Look, if I plug in 43 right there, it will still work. 2 times 43 plus 10 also equals 96. Does everybody see? You can plug it into the not simplified answer or the simplified answer. Right? Makes sense. Same thing. One's more simplified. This is how you're going to see it on a multiple choice test written. So that's why I want you to practice going that far. Okay, let's write the explicit formula, not the explicit, the recursive formula. This is the easiest one to write. What did we see happening? Didn't we take the previous term and add 2? Every time. So you'd say a sub n is equal to the previous term, right? A sub n minus 1, that's what previous term means. And then we literally just added 2 each time. Super easy to write, because it's just what do you see happening? But now I'll show you why that doesn't help you. If I said, find the 43rd term, and you tried to use this formula, look what happens. A sub 43 is equal to a sub 43 minus 1. Wouldn't that be a sub 42? Plus 2. Do we even know the 42nd term? If we did, we'd just add 2 to it, and we'd be there. Do you see how that's not useful? We're like, we don't know. We can't still solve it. But what's the point? Yeah, good freaking question. I don't know what the point is. They are going to ask you, write a recursive definition. What? Yeah, so, and we could use it for find the 5th term, but if we do that, let's just add 2. Okay, cool. That's what we're doing. Okay, let's do number, that was 11. Let's do 12. Okay, I am having you for practice, so you might want a separate sheet of paper. You're going to write, because you're going to need to practice this for the test. We're going to write out a general explicit formula, a recursive formula, and then we'll find the 43rd term. So we would say an explicit formula is a sub n is equal to a sub 1, which is 13.1 plus, we're leaving it general right now, n minus 1 times by the common difference. So let's quickly find the common difference. This minus this is negative 10. This minus this is negative 10. This minus this is negative 10. Oh, yes, he's right. Our common difference is negative 10. This is a times sign, everybody. Don't be the person that subtracts it. It's times by negative 10. Now, because I said the multiple choice test will have it simplified, let's just do it right now. Let's take negative 10, multiply it in. So we have our general formula for any term will be 13.1 plus negative 10n, and then is it negative 10 times negative 1 plus 10? So any term, a sub n, is equal to, let's write it in standard form. So that would be negative 10n, 13.1 plus 10, plus 23.1. There's our simplified explicit formula. Okay, let's write our recursive formula. What are we doing each time? Take the previous term and then subtract 10, right? Take the previous term, subtract 10. Isn't that what we're doing each time? So our recursive formula is a sub n is equal to any term in the sequences, take the previous term, and subtract 10. Which one would we want to use to find the 43rd term? This one. That's not going to help, right? We don't know the 42nd term. So let's plug in a sub 43. So then we would have negative 10 times 43 plus 23.1. A sub 43. Our 43rd term is what? Negative 406.9. That is awesome. That's our 43rd term. Can you guys do it by yourselves? Do you need another example? Okay, here we go. So we would say an explicit formula. Isn't this a sub 1, everybody? Agree? So we'd say a sub n is equal to a sub 1, which is 27 plus n minus 1 times by the common difference, 18 minus 21. 21 minus 4. 24 minus 27. So our common difference is negative 3. Do you see how I multiplied it? So let's simplify it. We have a 27 times negative 3n. So wouldn't that be negative 3n plus 3? So then a sub n is equal to negative 3n. And then 27 plus 3. 27, 28, 29, 30. True? Plus 30. There's our general explicit formula. If I asked you to write a recursive definition, you would say, I take the previous term, subtract 3. Subtract 3. Okay. A sub n is equal to a sub n minus 1, the previous term, and then we're going to subtract 3 from that. Find the 43rd term. A sub 43, we only would use the explicit formula because recursive is not going to help us. So then we have negative 3 times 43 plus 30. Our 43rd term. Negative 99. Pretty easy stuff, right? Pretty straightforward. Okay, do 11 through 20 go. Students will be like, oh yeah, we've already done that. So if I said to you, find a sub, or find what n is, find n, that means find what term 52 is. So we know this is a sub 1, this is a sub 2. If this is a sub 20, for example, does not mean that's the 20th term. Okay, so if that was a sub 9, we'd know that's the 9th term, right? So then we would know, listed here, if that was really the 9th term, then listed here would be 9 terms. Correct, everybody? Okay, so let's find what n is. We're not finding a sub n, we're finding n. So you'd say it's arithmetic, so let's set up a truth statement. Arithmetic equations work like this. A sub n is equal to a sub 1 plus n minus 1 times by d. True? Let's plug in everything we know. We actually know what a sub n is. The last term is 52 is equal to what's a sub 1? Plus, we don't know what n is, do we? N, that's what we're solving for. Good point. N minus 1, what is our common difference? Yep, times by 7. And now look, solve for n. So wouldn't I subtract 3? So that's 49 equals, and then we have this, n minus 1 times by 7. So he's saying divide by 7. Does everyone agree with him? So now we have 7 is equal to n minus 1. So n equals 8. So you're saying this is a sub 8? That is true. That's the 8th term. So how many terms are listed here? 8. Okay, awesome. Okay, all right, let's go to 21. Let's get this in before lunch. Then you can come back and work on it. If you've already done this section, you need to watch because I'm going to teach 2 different methods. And there are times when you cannot use one method or the other because it won't work. When we get to more advanced ones. So watch both methods. So if I said to you, find the missing term right here, like x, for example, we could do this by this method first. So you got to know how to do both. You all hear me. You have to be able to do both. Okay. So this is method number 1. Let's set up a true statement. Isn't it true to say, starting with 23, aren't we going to add some amount and get to here? And then aren't we going to add that same exact amount and get here? So what would my true statement be? 23 plus question mark plus that same question mark equals 49. So then we have 23 plus 2 question marks equals 49. So then subtract 23. So we have 2 question marks equals, subtract 23. What is this? I hear somebody saying 26. They're right. Divide by 2. So what's question mark? 13. So we're saying that we added 13 each time. Okay, that's true. But that was solving for what we added. So we would do 23 plus 13, which is? So you're saying x is 36. True. How can we know we're right? Because add 13 again, you should get at 49. That was method number 1. That's going to be the most useful method if I start spreading this out more. If I put another box and then put something, you're going to have to use that method. You're going to have to find for what you were adding each time. Now here's the other way though. So everybody that's already done it, you saw this connection. So this is method number 2. We can solve directly for x. I'm very algebra minded. Those of you that have already done it, you're doing the same thing I am. You're just thinking about it. So don't get too thrown off about it, okay? I'm an algebra woman, so let's pretend we don't know this is 36. We're calling that x, true? So let's solve directly for x. You do need to know how to do it this way too. Let's set up a true statement solving directly for x. I'm going to erase that stuff so we're not confused. Okay, so here we go. A true statement. Don't we take, if it is arithmetic, wouldn't this minus some amount be the same as this minus this? Because it's the same difference every time. So let's set up that true statement. 49 minus x, 49 minus x, you got to go in the correct order, will equal x minus 23. So now let's solve for x. So we'd add x. So then we have 49 equals 2x minus 23. So then add 23 over. So then we get 72 equals 2x. So then divide by 2. So x equals 36. And that was solving directly for that value. Just 2 different true statements, but we're solving for 2 different things. Yes, he's making a good point. He's saying if we had another box here, if we had 2 x's, we couldn't solve by this method because those x's aren't the same x's. You'd have to solve by method 1. Okay, I want you to now practice 21 through 32 with the method of your choice. You do have to be able to do both methods. Are thinking of it like this. They're saying, okay, we don't know what that is or that, so they're going 2. We do know have a true statement. Starting with 2, if we add something, we're going to be here. True? Add something again, we'll be here, correct? Add that something one more time, and that puts me here. So 2 plus 3 question marks equals 23. So subtract 2. 3 question marks equals, it is 3 question marks. Start at 2, add something, get here. Add something, get here. Add something, get here. Do you see how many add somethings I said? So 3 question marks, subtract 2 equals 21. So divide by 3, question mark equals 7. So we're adding 7 each time. So 2 plus 7 is 9. Add 7 is 16. Does everybody see? Yeah. What throws people off is they don't get in enough or they get in too many question marks. So draw out a picture like I did. So do the next one. Some people already did it. Somebody said up here that we're adding 8 each time. Oh, I thought it was 2. I thought it was 8 too. I forgot. Okay. That's okay, huh? Yeah, he was thinking 3 spaces. So we would add something and get here. Add something, get here. add something again, get here, add something again, and finally end up where we need. 3 plus 4 somethings equals 27. Subtract 3, you get the picture. Moving on. Okay, so let's look at 35. It says, find the arithmetic mean, a sub n, of the given terms. Given that a sub n minus 1 equals 5 and a sub n plus 1 equals 11. Now, I want you to notice something. This is worded really weird. So, like, you can't, sometimes you're going to say, I don't know what's going on. You don't just say, this person's I don't know how to do it. Instead, you say, let's see if we can decipher this. So it says, find the arithmetic mean. Don't know what that is. I do, but we'll get there. It says, find a sub n. I'm going to write that out. It says a sub n minus 1 is 5. So where should I put the 5? Oh, look, you're thinking without Miss Christensen's help. Okay, awesome. What does a sub n plus 1 mean? We're about to get there. So you're saying that's that, right? So you're saying we have this, 5, comma, we don't know, comma, 11. We're doing the same thing on the front. Now here is why it's called an arithmetic mean. You will see that word again. I will say, and I've seen this on the end of level test. They say, find the arithmetic mean of 5 and 11. You have to know what that is. So let's make sense of this. Look, since we only have 2 things, if you find the halfway mark, it's the average. Average means mean. You're finding the average, the halfway distance, which is what we're finding here. Does everybody see? So what we were doing with the other 2 formulas is we were finding this value, which is the halfway distance, which is the arithmetic average. Arithmetic because it's addition. Does that make sense? Okay, so ready, go, solve it. So however you were solving it before, I'm just going to go right for it. Finish up that section, 35 through 40, go. In RealWorld Problems. So here we go, 46. So let's read it, because you've got to read these a little bit carefully. It says, each year a volunteer organization expects to add 5 more people each year to the number of shut-ins, whatever, who the people provide home maintenance services for. This year, the organization provides the service for 32 people. So basically, these guys go around and they maintenance houses. Let's just make it simple. It says every year they plan to add 5 more people. This year they do 32. So it says write a recursive formula. Let's go to B. It says write out the first 5 terms of the sequence. So what is A sub 1? On the first year, how many people did they provide maintenance to? 32. Then every year after that, didn't it say they added 5 more people? Yes. So this business is growing each year by adding 5 more people that they're going to service. So this is, if they stay consistent. So our A sub 2, A sub 3, our 3rd year, our 4th year, our 5th year. Let's list this out. On the 2nd year, you add 5 and you get, they will clean 37 houses. And then the next year they'll clean 42 houses. And then the next year they'll clean 47. And in the 5th year they'll clean 52 houses. So it's staying consistent. This business is staying consistent. So now it says write a recursive formula. This is the easy one to write, not usable. A sub n minus 1, you take the previous term and you add 5. Write an explicit formula. That's the formula that we need to have memorized. A sub 1 is, on the first year, they did 32 houses, plus, we're leaving it general, n minus 1 times by the common difference of 5. We would then simplify that in, so we would have A sub n is equal to 5n, putting it in standard form, and then 32 minus 5, which is 27. So there's the general explicit formula. So why would that be useful? Because let's pretend that somebody wants to know, in 20 years, if we stay consistent, how many houses are we going to be cleaning? So how much projected growth do we need to be prepared for in 20 years? So we would say A sub 20 is equal to 5 times 20 plus 27. How many houses will they be cleaning? 127 houses. They're going to have to hire some more employees. So as you can see, story problems are really no different. So finish up the entire worksheet. Before you hand it in, show me real quick.
Which one?